So in this class, we'll discuss about another coefficient called rank correlation coefficient denoted by rho. So we have learned about correlation coefficient and also regression lines. Here, suppose if two sets of data are given, x and y, some values are given. For example, I will take 40, 60, 55, 75, something like this. And y values also I will take 80, 72, 60, 38, something like this. Now, in this case, what we have to, if you are asked to find the rank correlation coefficient, first we have to assign ranks to each variable. For example, x has got these values. Among these, the highest value is this 75 is highest value. Next comes 60, next comes 55, next comes this 40. So we have to assign the ranks 1, 2, 3, 4 for them. So starting from the maximum, we have to move towards the minimum. Similarly for y, so the highest value is this 80, then this is second, this is third, this is fourth. Now after this, what we have to do is, after assigning the ranks, we have to take the difference between these ranks. For example, this difference is, that is x minus y we have to take. So for each set of data, we have to take the difference. So this x minus y, that is 4 minus 1. So x minus y means that is the difference between the ranks. You can say that as d. So d is the difference between the ranks of x and y. So this becomes 3. Similarly, for the second one, it is 2 minus 2, which becomes 0. Then 3 minus 3, which becomes 0. Then 1 minus 4, which becomes minus 3. So d is the difference between the ranks of the set of data. Then after this, we have to find out d square. Then we have to find out sigma d square. Then we can find out the rank correlation coefficient using the formula rho is equal to 1 minus sigma d square divided by n into n square minus 1. So this is the formula we have to use to find the rank correlation coefficient rho. So here, so this 1 minus, so 1 will be there here. So 1 minus this entire thing. So this is what the formula is. Here n is the number of observations of data. There are 4 here. There are 4 observations. So n is equal to 4. So after getting the sigma d square, we can find out the 6 into sigma d square. 6 times sigma d square divided by n into n square minus 1, where n is the number of observations. So here in this case it is 4. So what happens here, if this as the value of sigma d square approaches 0, or d square if it approaches 0, or d if it approaches 0, then this numerator becomes 0. You can say 6 into sigma d square becomes 0. When numerator becomes 0, so the value of rho will be equal to 1. So 1 minus this becomes 0. 0 divided by anything is 0. So rho becomes 1. That means if there are no deviations in the ranks of each set of data, then its rank correlation coefficient will be equal to 1. That is the highest. Maximum value is rho is equal to 1. So if there are no deviations, that means all the values, if all the values, the difference values are 0, the meaning of that is this is also first rank, this is also first rank, second rank, third rank, then fourth rank. Eventually if you get, then the differences also will be 0. If you add them, that is also 0. And the sigma d square will be 0. 1 minus this thing will be 1 minus 0, which is equal to 1. So this is the concept. Now let us take up a problem of finding rank correlation coefficient for a set of data. So in this problem, he has given the marks secured by 10 students. Marks secured by 10 students are in 2 subjects. Marks secured by 10 students in 2 subjects. So x gives the marks secured in first subject, Y gives the marks secured in second subject. Now let me take the values like this. Out of 100, let us take the marks. So this is data given. Out of 100 marks, the first subject, the X represents the first subject, Y represents the second subject. 68, 64, 75, 50, 64, 80, 75, 40, 55, 64. So these are the values, X values. Say marks secured by 10 students. There are 10 students. So N is equal to 10 here. 10 readings will be there. In another subject, Y, the marks secured by the first, these are the first student, second student, like that they have taken. For the first student, he has secured 62. Second student has secured 58. Then third student 68, 45. Fourth student, fifth student 81. Sixth student 60. Seventh student 68. Eighth student 48. Ninth student 50. 10th student. So these are the marks secured by the 10 students. So first set of marks, XY marks 68, 62 by first student, second student, third student. There are 10 readings here. Therefore, N is equal to 10. Now to find out rho, we have to find out sigma d square. Once you find out sigma d square, just by substituting in this, we can simplify. So before that, we have to assign ranks to these values. So first what I will do here is, I will make another table, rank of x. So I will take x, so rank of x. Rank means there is 1, 2, 3, 4 like that. Then y, rank of y. Rank of y. Then I have to take the difference between the ranks. The difference between the ranks, I will take it as d. Then square it, d square. So this is what we need. Yes. So here, if I take this as first, second column, third column, fourth column, this fifth column is given by second minus 2. And we have to square it. So this is what I have to do. Now I will write down the values, given values, 68, 64, x values I will write, 68, 64, 75, 50, 64, 80, 75, 40, 55, 64. So these are the x values. So I will write the corresponding y values given for this set of x values. So we will form the table. Yes. Now set of y values I will write 62, 58. The rows will be converted to columns. Then 68, 45, 81, 60, 68, 48, 50, 70. Now once you write this in the form of columns, now we have to assign ranks to these values. As I already told, the highest value in this will become the first rank. So this 80 is the highest value, this becomes 1. So we have to move from the highest to the lowest. So 80, then after that 75 is there. 75, okay, this I will take it as 76 or 72. I will take this as 72. Okay. Now 75 is there. 75 I will take it as second rank. Then 72, third rank. Third rank is 72. Then comes 68. 68 is the fourth rank. Then, okay, here 64 is also repeated. Let me take this as 66. Actually, values are repeated, then there is another formula. We'll discuss it later. So 66. So now after this 68, there comes 66, that is 5th rank. Then 64, 6th rank. Then comes 64 is also repeated. Huh? Yes, that is also repeated. So let me take this as 62. 62. I will make this as 62. Okay. So 64 is 6. Then 62 becomes 7. Then 55 becomes 8. 50 becomes 9. 40 becomes 10. So these are the ranks. Then the second set of data, here also of course 68 is repeated here. Let me take this as 67. Any other value is repeated? No. Okay. Now for the second, for the values of y, we have to assign once again the ranks. So the highest value is 81 here. So that becomes 1. Then second highest is 70. This becomes 2. Then I think 68, 3. Then 64, 67, 4. Then 62, 5. Then 66. Then 58, 7. Then 58, 50 number is 8, rank number is 8. Then 48 is 9, 45 is 10. Okay. So this is how we have to assign the ranks. So I have taken different values here. Suppose if there are some common values, then formula is different. I will take it later. Now I have taken different values. Now the difference between these ranks, right values, is your D. Now let us find out D now. This x minus y. So this, that is column 2, number column 4 is the difference in the ranks. So 4 minus 5 is minus 1. 6 minus 7 is minus 1. 2 minus 3 is also minus 1. 9 minus 10 is also minus 1. 7 minus 1 is 6. Then 1 minus 6 is minus 5. Then 3 minus 4 is minus 1. 10 minus 9 is 1. 8 minus 8 is 0. 5 minus 2 is 3. So these are D values. You have to square them. So minus 1 square is 1. This is also 1, 36, 25, 1, 0, 9. This is D square. So all the D square values will be positive, because even if it is negative when you square it becomes positive. Now we have to add these values to make sigma D square. So sigma D square will be 1 plus 1, 2, 3, 4. 4 plus 36, 40, 40 plus 65, 25, 65, 65 plus 166, 67, 76. So sigma D square is 76. Therefore, rank correlation coefficient rho is equal to 1 minus 6 times sigma D square divided by n into n square minus 1. So you have to remember this formula. So if you use this formula, 1 minus 6 times 76 divided by n is 10 here, number of observations, into 10 square minus 9. So this is the substitution. Now if you simplify this, so you will be getting 6 into 76 divided by, this is 10 into 100 minus 1 means 99. 99 into 10 will be 990. So 6 into 76 divided by 990. That becomes this part. So it is 1 minus 0.46. Therefore the value is 0.5. So the correlation, rank correlation coefficient value is 0.54. So we have to assign the ranks based on the set of data given, starting from the highest. The highest value is rank number 1. Lowest value becomes rank number 2. So this is the procedure. So give the ranks for each set of data x and y. Take the difference between those ranks, and then that becomes D. Then you square it, then add it, then use this formula. This is the meaning of rank correlation coefficient. Suppose for the same set of data, if you are asked to find correlation coefficient, then we have to use this formula which we have used earlier. R is equal to sigma xy divided by square root of sigma x square into square root of sigma y square, where this x is nothing but x minus x bar, y is nothing but y minus y. So we can find out correlation coefficient using this formula and rank correlation coefficient using this formula. You can try this same problem for R. So if you can check whether R is greater or Y is greater.